Assalamualaikum. Fahad Hassan registration number 16 TE10. Today it is week 13A lecture, which is based on Z transform and inverse Z transform. Now formula for Z transform is, for discrete time signal, x of z is summation n equal to minus infinity to infinity x of n z of minus n. Now what is z? Z is basically complex variable, which is also called as discrete Z transform. Now why use Z transform? To find region of convergence of signal, and another use is to check where signal converges and where signal does not converges. Region of convergence also defines stability of system. To check where system converges and where system diverges is one of the uses of Z transform. Now coming towards the example. Now we have a set x of n equal to these. Now if we need to calculate the Z transform, we will apply the formula, and after applying the formula, x of z will come out to be 1 plus 2z raised to the power minus 1, and so on. Now no term involving z in denominator, so no poles, because poles are always calculated from the denominator and zeros are calculated from the numerator. So R of z will be the entire Z plane. Now this was some brief introduction about Z transform. Now a brief introduction about inverse Z transform. The formula for inverse Z transform is x of n equal to z raised to the power minus 1 into x of z. Now basically this is called the inverse Z transform operator. Now what are the methods to find the inverse Z transform? Number one method is partial fraction method, which will be discussed in this book. The other two methods are out of our scope, which are power series expansion and residue method. Now consider this example 5.8, where we have given that there are two Z transforms. We have to calculate their inverse Z transform. So solving a part, we will apply Z inverse operator to each and every term, and after, now we know that they are already in the fraction form. So after looking at the lookup table, which is on our textbook Lee10, we will get the following answer. Now one important thing to note is that it is linear combination of basic signal. Now similarly part B can be solved. This one, applied each and Z inverse to each and every term, we got x of n, which was again a linear combination of basic signals. Now what can we conclude? We can conclude that we learned how to apply Z transform on discrete time signal or n domain. Just what we have to do is that apply Z transform to each and every term and look at the lookup table to find the Z transform, and we also learned how to get x of n from a signal which is already given in Z domain. For that, simply we have to apply the inverse Z operator. Thank you for watching.